Hello everyone, it's me Gagan Kumar present over here to teach you physics. Let's move on to the video. Today we'll be discussing MCQ on De-Broglie wavelength. So here we'll be seeing what is the formula for De-Broglie wavelength for different particles like electron, proton, alpha particle like that, along with some wavelength related questions. Okay, so matter wave related questions will be solving here. Now come to the question number 1. So here they are telling an electron is accelerated from rest through a potential difference of V volt if the De-Broglie wavelength is 1.227 into 10 to the power minus 2 nanometer, the potential difference is how much? Some here options are given. Okay. So understand here. So here De-Broglie wavelength formula is h by p. So if a material particle moving with velocity v, then the De-Broglie wavelength associated with that particle is nothing but h by p, and p is nothing but momentum of that particle. So p equal to mass times velocity. Now this lambda equal to h by mass times velocity, h by mv, and here also you can write as h by 2me, where E is nothing but is the energy of this particle. So kinetic energy you can take, kinetic energy, so it is basically p square by 2m, and also you can write as wavelength is nothing but h by 2m q times v. Suppose a charged particle is moving in a potential difference v, then what will happen? So remember, this is your small v, this is your velocity. So it is your small v, it is your velocity of the particle, capital V is the potential. So it will come basically what? Potential will come. So here if a charged particle moving in a potential v, then its wavelength will be how much? H by 2m qv. Now in this charged particle q, if we will take one electron, so if I will take an electron, so for electron, so what will happen? Now your wavelength will be h by 2 into mass of electron into E, E means electronic charge, into potential. Suppose it is accelerating with a potential V. If we will put all the values here, h value, so h is called basically Planck's constant, so h is nothing but it is your Planck's constant, and mass of electron and charge of electron we know. If everything will substitute, we will get for electron how much it is? 12.27 divided by root under V angstrom. Okay. So remember this formula directly to solve the MCQ. So no need to go for this calculation and all, it will be hectic calculation, because h value to substitute, mass of electron to substitute, electronic charge you have to substitute. After substituting you will get this. So directly we are writing in angstrom unity, so 10 to the power minus 10 meter unity. So 12.27 by root under V. Now see, they are asking here V, so they are asking potential, and this wavelength is already given for electron. Now in this formula we need to substitute this and we need to get this root V. Okay. So now let me substitute here 12.27 by root V angstrom. Now here in place of lambda if I will substitute 1.227 into 10 to the power minus 2 into 10 to the power minus 9, this will become 12.27 divided by how much? Root V into 10 to the power minus 10, because 1 angstrom is 10 to the power minus 10 meter. Now here 10 to the power minus 9 will cancel 10 to the power minus 10 as 10 to the power minus 1, and here I can write root V, I can take this side, but here you see this value into multiplication of this value will give you 1.227 divided by root V. So easily you can cancel this with this. Then after here I can write root V equal to nothing but 1 by 10 to the power minus 2, which is 100, or 10 to the power 2. Now if I will take V square, I will get 10 to the power 4. That means what my answer coming? Now my voltage will be 10 to the power 4 volt, 10 to the power 4 volt. Okay. So remember, if this equation is there, this wavelength is given, then easily your answer is coming 10 to the power 4 volt voltage. So if you know this formula, this is the wavelength of electron with the voltage, the relation. This is not velocity, this is your potential, okay, electric potential. So when charge particle is moving in a potential, so this relation you can write. So 12.27 by root B into angstrom unit will be there. Suppose electron, then you can use this formula. So specifically give for electron. Suppose it is a proton, then the same formula will get changed as 0.286 by root B into angstrom, where B is the potential difference. Okay. So remember, when a charge particle moves in a potential, then after this type of wavelength is coming for that particular charge particle. Now here lambda of alpha particle also you can write. Lambda of alpha particle is 0.101 divided by root B into angstrom. Okay. So this formula, remember, if a potential is given, directly substitute, then you get your answer of the wavelength. So mostly electron or proton and alpha particle they will ask. Okay. So here remember it is for proton. Now next we will go to the next question. You will understand based on this formula, lambda equal to h by p or h by mv or h by root under 2me or h by root under 2m qb. Okay. So here this is the for electron, just remember. Now next come. So here an electron is accelerated from rest through a potential difference of 10 to the power 4 volt. So here potential how much given? 10 to the power 4 volt. Now given it's the if the De-Broglie wavelength is nearly what? So here they are asking what is the De-Broglie wavelength and potential is given. Just now you understand. So here they are telling basically about electron. So wavelength of electron is nothing but 12.27 by root B into angstrom will be there. Angstrom unit you can tell. Okay. So angstrom unit it will be there. Now here you can write lambda is nothing but 12.27 by root under 10 to the power 4. Angstrom means 10 to the power minus 10 meter. Now 12.27, so 10 to the power 4 will come as 10 to the power 2, root under is there, so it will come up, means it will become 10 to the power minus 12 meter. So if we check this answer, it will come around C option, that is 12.2 into 10 to the power minus 12 meter. So if you remember this formula, then easily you can calculate for MCQ. If you don't remember this, then you have to struggle with that lambda equal to h by 2m E into V for electron. After electronic charge you have to take, and here you have to consider as a mass of electron. Okay. So you have to calculate based on that. So if you remember this, then easily you can get the answer. Now go to the next question. So here an electron of mass m with an initial velocity v equal to v naught I cap. So v vector given initial velocity, that is your v naught I cap. Okay. So v initial you take. So it is moving in the electron is moving in the x direction, positive x direction, enters an electric field E vector, so which is nothing but E naught I cap. So here electric field is given how much? E naught I cap at a t equal to 0. Then if lambda naught is De-Broglie wavelength initially, then its De-Broglie wavelength at a time t is how much? At a time t is how much? So here what we will do? Now here De-Broglie wavelength at a time t means they are asking at initially lambda 0, there is nothing but h by mv naught. So this is the wavelength is given. Now at a time t, your lambda wavelength is lambda t, suppose, that is h by mvt. So you need to find the magnitude of velocity at a particular time t. Then after you can check, some options are given here. So consider lambda naught is what? Velocity at a t equal to 0 or initial velocity, and its initial velocity h is constant and mass of electron is constant. So we need to work with this formula, no need to use any other formula, but here you need to find this Vt in terms of this lambda naught. We have to take what is your lambda t. Now understand, when a charge particle q moves in a electric field, that time what happens? Now that time a force acts on the charge particle, that is called Coulomb's force, Fe, and that is how much? Now q times charge times E vector, and this charge you have to put with sign as you are writing vector form. If positive charge positive sign, negative charge negative sign. Suppose you are taking electron, then here this q will become minus E, and E vector already given here, it is minus E naught I cap. So that means it is coming E naught I cap. So that means your electric field in left direction, it is your electric field, and electron is moving towards the right with velocity v naught initially, but at time t will calculate what is the velocity. Okay. Now understand, here if I want to find acceleration of the electron, then it will be Fe by m, mass of the electron, so it will become E naught by m into I cap. Now if the velocity of the electron I am finding at a time t, that is Vt, then how much I will write? V naught vector plus acceleration vector, remember this vector wise coming, into time t. So it is your kinematic equation you are using, final vector equal to initial vector plus acceleration into t. So here I can write V naught I cap plus E naught by mass of electron into t, and here it will be I cap. Now if you will check this one, it is V naught plus E naught t by m into I cap. So this is your velocity at a time t. So listen, first velocity at a t equal to 0 or initial velocity was given. So this was initial velocity, you can write also Vi, no issues, and it is your V final. So V final is V initial plus acceleration into t, and acceleration you got from this force, because they have given electric field and this charge particle is electron here. So force equal nothing but E naught I cap. So you are getting Vt is this much, that means if you want to write Vt magnitude, how much will come? E naught into t divided by m, and here one V naught also will be there. So this will be coming here, what? Velocity magnitude, okay, because I cap magnitude is 1, so it will be velocity. Now here if you want to calculate wavelength, then at this Vt we need to substitute here. So if we substitute here, definitely it will come h by m, and here I can take V naught common, so it will become mv naught 1 plus E naught t by mv naught, like this one expression will get. Now here h by mv naught is by nothing but that is lambda naught. I will check this expression exactly option A will match with this total value h by mv naught is lambda naught, so lambda naught by 1 plus E naught t by mv naught. So this is the thing you have to do here. So remember, so from here you are finding what is the magnitude of this Vt. So this is the magnitude, because I cap magnitude is 1, it is a unity vector. So this one you have to substitute here, and V naught take common. While taking V naught common, definitely here one V naught is there, here no V naught. So definitely here one V naught will come when you are taking common V naught. And this h by V naught is nothing but that is your lambda naught. So in the last expression if you want to write, I will write lambda naught by, so your lambda t is nothing but lambda naught by 1 plus E t by mv naught, mv naught. So this will be answer. So answer will be option A, E naught t by mv naught. Okay. So this is the idea. Remember, whenever this type of field and force and acceleration you need to consider, and if they given lambda naught, you can find lambda t in terms of lambda naught. Now I will go to the next question. Now here they are telling the De-Broglie wavelength of a neutron in thermal equilibrium with heavy water at temperature T and mass m is given like this. Now remember, De-Broglie wavelength is called basically lambda, and this lambda of a neutron you want to find. But you know lambda equal to h by p, and you know lambda equal to h by mv, and you know lambda equal to h by 2m qv. Also you know lambda equal to h by root under 2me. Now whenever a neutral particle you are taking like a neutron, that time this energy will be basically thermal energy. So due to temperature T, so what is thermal energy will come? Now that is 2m, E will become 3 by 2 kBT, 3 by 2 kBT. So thermal energy is coming here. So E equal to how much you are taking? 3 by 2 kBT. Now here this 2 getting cancelled. So how much you are getting? H by 3m kBT root, 3m kBT root. So this is your wavelength lambda. So here option A is exactly matching with that h by root under 3m kBt. So, remember if a neutron is there, so neutron charge particle you cannot give potential to this and all. So, this term you cannot use. So, to use this formula that P equal to root under 2me and here E you have to change as what 3 by 2 kBt, then you have to get the answer. So, K is called what basically Boltzmann constant. So, this K and T is the temperature in Kelvin. Okay. So, this is the idea you are understanding. Now, I will go to the next question. Electrons of a mass m and a photon, so one electron of mass m take and a photon have same energy E, the ratio of De-Broglie wavelength associated with them is how much? That means you are having wavelength of electron and wavelength of photon, So, that ratio you need to find, and here they are telling energy for both of them is same. So, both have energy E. Now, see how to find here. So, lambda electron is how much? Now, you know h by 2m E you can write, or h by p you can write, or h by mb you can write. Okay. So, h by root under 2me. So, because you are telling energy same for both, so this expression will be suitable here. Now, lambda of a photon if you will consider, that will be how much? Now, this one we have to calculate from energy of the photon. Remember, energy of the photon equal to how much? H times nu is called frequency, or you can write hc by lambda, because nu equal nothing but c by lambda. So, hc by lambda. Now, if photon wavelength you will check, so here photon wavelength is coming how much? Now, lambda photon will be coming hc by E. So, that means here I can consider h by root under 2me is the wavelength for electron divided by h by hc by E, this is for hc by E, this is your wavelength of photon. Now, here definitely HH will get cancelled. So, I can write this one as E will go up. So, 1 by C, 1 by root under 2me into E. Now, here if you will cancel this root E with E, so I will get 1 by C root under E by 2m. So, this is the lambda of electron by lambda of photon, So, here what answer you are getting? You are getting 1 by C E by 2m to the power half. Okay. So, this is the wavelength ratio of electron and photon if energy for both of them is same. Okay. So, this is the relation is coming. So, I hope you understand. So, this is the idea you must remember for De-Broglie wavelength. If energy given or momentum given or velocity given or a charge particle moving in a potential, then how to find De-Broglie wavelength you are understanding in this discussion. Okay. We will be uploading more videos. Keep watching the video, like and subscribe Vidhyalakshmi NEET Academy YouTube channel. All the very best. Thank you so much.